Thanks for joining with today's Northern Grape Project webinar. My name is Janet Van Zorn. I'm the support specialist for the New York Statewide Viticulture Extension Program, and I'm going to be the moderator and will provide technical support today. A quick announcement that the next webinar in this series will be on February 7th, discussing the complex nature of sour rot management with Megan Hall from the University of Missouri, and we'll provide some more information about registering for that at the end of today's talk. So to start off, you can open the chat bar at the bottom of your screen and use it for introducing yourself, making any comments, and to alert me if you're having technical difficulties. Just change the chat settings to send to all panelists and attendees so everyone can see your introduction. If you'd like to ask questions during the presentation, please use the Q&A button on the menu at the bottom of your screen. We'll have time at the end of the presentation for questions, but you can type them in at any time during the talk. Additionally, Amaya will provide her email address, so you can email her directly to ask any vineyard-specific questions or any that we don't get to today. Our speaker today is Amaya Tucha. She's an assistant professor in the Department of Horticulture at the University of Wisconsin in Madison, and the fruit crop extension specialist for the state of Wisconsin. Her research program focuses on fruit crop physiology and production practices, and today she'll be talking about fruit zone sunlight exposure in cold hardy wine grapes. So with that, I'm going to turn it over to Amaya, and I'm going to mute up and let her.
Thank you, Janet. I'm going to share my screen. Hopefully everything's going to go smooth here.
Okay. Yep, we can see it.
Perfect.
Perfect. All right.
All right. Well, thank you very much for inviting me to give this presentation. And what I'll be presenting today is part of some of the studies that we've been doing here in southern Wisconsin, and specifically looking at the impact of increasing sunlight exposure to the clusters and how this is affecting the fruit compositions of cold climate hybrid grapes. I just want to give a little bit of context of why we decided to start some of these studies, and also tell you a little bit about our specifics on how our growing season might be different from a lot of you that are attending right now this webinar, and how that you can make that connection to relate of how your sites and your growing regions might be a little bit different, and how maybe the results of our studies might or might not apply to your regions. So just to start, I want to talk a little bit about the growing season here in southern Wisconsin. We have a relatively short growing season. So overall, if we average in general the growing degree days from April 1st until around mid-September, that's when we generally start harvesting, we accumulate around 2,500 growing degree days in Fahrenheit. For those in Canada, it's around 1,400 in Celsius. So it's a relatively short growing season. We have had several incidents of spring frost, even in mid-May. So the season starts relatively later, and we don't get excessively warm. In addition to that, we have had very wet years, especially in the spring, but also during harvest. So in general, we can get anywhere between 5 to 10 inches of rain during the month of August and September, right when we're trying to get the final push on ripening the fruit before harvest. We have pretty fertile soils with high organic matter, which in addition to high precipitation results in vines that tend to be very vigorous. So we have to deal a lot with very big canopies and shading fruit. That's one of the problems that we have. That is part of the nature of these hybrids, these cold hardy hybrids that tend to be way more vigorous than vinifera cultures. And in terms of yield, we have moderate to low yields in this area. We would say we average close to 4 tons per acre, or maybe between 10 to 15 pounds per vine. So relatively moderate to low yields. So this is the scenario that we have here in southern Wisconsin. And under this scenario is where we started thinking about, what are the challenges that we have in terms of ripening the fruit on time and achieving certain standards of quality that we want to be able to produce high quality wines. So cold hardy grapes or cold climate hybrid grapes have their specific characteristics in terms of fruit quality. One of them that everybody's very aware is their high acidity. Mostly malic acid tends to be pretty high in these cultivars, and this comes from the background from the Native American grape, the Vitis riparia, that has been used in the crosses, and it's kind of imparting this high acidity in the wines. So high acidity in the fruit resulting in high acidity in the wines are perceived as wines that tend to be tart, thin, and also referred to green or hard wines. So I have this little table down there that compares Vitis vinifera cultivars with these hybrids, and you can see in the total acidity, I don't know if you can see my cursor here, but the total acidity here, you can see a very general and average range for vinifera cultivars would be between 6 to 7, while hybrids in this region and from all the years that we've been collecting data, we usually have between 9 to 17. So it's substantially higher, and mostly due to the malic, the contribution of the malic acids. We have been monitoring TAs and malic and tartaric acid for a while in our harvest here, and we usually have anywhere between 6 to 14, depending on the cultivar. There's great variation between the cultivars, but not so much difference with the tartaric. So most of it, as I say, is due to the malic acid contribution. In terms of sugar, or what we measure as Brix, we see that the levels are pretty much comparable to Vitis vinifera cultivars. We tend to achieve, almost the same range of Brix, and we don't see a major difference. However, another difference in terms of fruit quality and the end up product, that's the wine with the red cultivars, is that we tend to have a little bit of problems with color in these red wines, and most of it is due to difference in the type of anthocyanins that these hybrids have. So in the case of Vitis vinifera, most of the anthocyanin, which is basically the main source of pigment in red wines, that's where anthocyanins are, tend to be what we call monoglucosides. But in the case of the hybrids, there are diglucosides. And basically the main difference is that the diglucoside anthocyanins that we find on cold hardy grapes are less vibrant in color. So we ended up with colors that might not be as intense. But this also affects the aging of the wine in terms of the color stability, because the cold hardy grapes tend to have low tannin extractability. So it doesn't mean that they have low tannins in their skins, but rather they are not available afterwards to combine with the anthocyanins to produce compounds that are more stable over time and that will help that wine age and preserve this beautiful color. So with all this in mind, the type of growing season that we have here in southern Wisconsin and some of the characteristic of the hybrids, the question that we had is there something that we can do in the vineyard to modify some of these characteristics of the cold hardy grapes? Well, we already know, because there's a ton of literature and many research on grapes, we know that temperature experience, the temperatures that the berries experience, are going to affect acid or the final TA, because temperature affects enzymatic processes, and the degradation of acids in the berries is driven by enzymes that will react differently depending on the temperature. So in general, higher temperatures are going to make those enzymes work at a faster rate and break down that acidity, so we ended up with grapes that have lower acidity. And we also know that light interception is critical for the development of anthocyanins that again are the main source of pigments in the skin of the grapes. And so if there's something that we can do to modify this, maybe we can end up with a better wine, which is what we're looking for. So what we did is we use a classic study that has been done quite a bit in many growing regions in the world in vinifera, that is just to do some leaf removal. So what you can see here is the treatment that we impose on these grapes. And I'm going to say we did this in many cultivars, but most of the results that I will be presenting today are for Marquette, Frontenac, Brianna, La Crescent, and also for Petit Pearl. That is a new cultivar. I don't know how many of you are aware of it, but it's a cultivar that at least here in Wisconsin, a lot of growers are planting and they're very interested in it. So what we did is we imposed a treatment of leaf removal. So about 2 weeks post fruit set, so when the berries were around a pea size, we went to the vineyard, and what we did is we removed around 2 to 3 leaves around the clusters. And then we also removed all the lateral shoots within the first 3 node positions in the shoot. And as many of you know, especially if you grow in Marquette, we have a lot of laterals. And in this area where we have fertile soils and a lot of rain, these vines tend to be even more vigorous, so we get a lot of laterals. So what we did, we went in, as I said, 2 weeks post fruit set when the berries were around pea size, and we removed 2 to 3 leaves around the cluster, and we also removed those laterals. So here's another example. You can see the controlled treatment on the left side, and then what we call the exposed treatment, in which we remove those leaves and those laterals on the right side, when you can already see we're past veraison and the grapes are changing color. And on the bottom, you have 2 images of how would a shoot look before the removal or during the removal, and then after when it's fully exposed. And yet again, another image. So you have, a visual of the 2 treatments. On the left, you have the control, and then on the right side of the screen, you can see how those clusters are exposed, and we will refer from now on as the exposed treatment. We only did this once during the growing season. We didn't come back and did more leaf removal. We applied once, and because I know that there's a lot of the growers that tend to do this. Some of the growers tend to do this closer to harvest time. We decided to do it early on, with the reasoning that the later you do this, there's less probably effect of the treatment, but also the berries are more sensitive to get sun damage, because those skins that have been growing maybe in the shade tend to be thinner. And so if you were to do it later, you might see some scald and some damage on the berries. So that's why we decided to do it a little bit earlier. So as I said, one of the things that we were interested in is to look at, are we modifying berry temperature? Are we changing berry temperature, and could this have an effect on the degradation of acidity? So the graph that I have here, what shows is on the y-axis, you have temperature, and on black is the temperature in Celsius, and on red, I put there the equivalent on Fahrenheit. On the bottom axis, on the x-axis, you have hours of the day, 0 being midnight, all the way again until the end here will be 24 hours. And so this line that you see right here on the middle separates, it's noon. And what the different curves show is the exposure, the temperature of the berries in the morning. You can see this portion here on the left side of the screen when the sun in the morning, and then the sun in the afternoon. The circles, the open circles and the open triangles are the exposed treatment, while the black circle and the black triangle would show the control treatments. Here's the legend. So what I want to show you is that in the morning, between the control treatment, which are the black circles, and the exposed treatment, which are the white circle, you can see quite a bit of a difference in the temperature. This is an average during the time from when we apply the treatments until we harvest, so it captures the entire kind of ripening period. And then if you look in the afternoon, we see also that difference in temperature, in which the exposed treatment, those berries tend to be warmer than the berries in the control treatment. During the afternoon, we didn't see as much of an effect versus the morning. We had higher temperatures in the berries that were exposed during the morning than during the afternoon. And part of it, I think, is that we tend to have a little bit more cloudy afternoons. And so when you have mornings that are brighter and have less cloud cover, you can really see that difference in temperature. And the image that is on the lower right corner shows how we measure this. We just inserted a little thermocouple in those berries, very close to the skin, so that we can monitor during all of these hours and this period of time the temperature of the berries. Another thing that we were interested in looking, well, does this treatment have an effect on how much sunlight those berries are intercepting? And so we placed some sensors to capture PAR, which is basically the photosynthetic active radiation, so how much light was getting into these clusters. And we monitored it again during the same period as the berry temperature. And this graph is set up the same way as the one before. What you can see in the y-axis is just the unit in which we measure sun and light, basically. And then on the x-axis, you can see the hours of the day, starting from midnight, all the way until midnight. And right here in the middle would be the middle of the day. So the legend is the same. These are the exposed treatment versus the control, and you can see quite a bit of difference between them in terms of how much light those clusters and those berries were receiving compared to the control. And in the afternoon, we see the same difference, quite a significant difference between both treatments. So what effect did this actually had in the juice and some of the wine that we made afterwards from these studies? So the first thing I have here, I have 3 graphs. They show Frontenac is on the top left, Marquette is on the top right, and then Petit Pearl is on the bottom. And it shows just the Brix at harvest. We did this study for 4 years. And what you can see if you look at the graph is that the bar with the stripe is the exposed treatment, while the solid bar is the control. So those clusters that were mostly in the shade, while the exposed received way more light. And you can see in general, there isn't a big trend in terms of difference between treatment for neither of the cultivars, of these cultivars. I just want to point out how Brix might not be as high, and how some years we ended up with very low Brix, years in which we have a lot of rain, and we ended up with disease pressure, and we really have to harvest early on. That is not unusual. We ended up having a lot of those in which everything looks perfect. During the entire growing season, we're approaching harvest, and then we get maybe 2 inches of rain and things start to break down, and you just have to go in and harvest. So that is something that happens quite a bit here in Wisconsin. But what I want to show is that in general, we didn't see a lot of changes in terms of Brix with the treatment, even though we had higher berry temperatures and also higher light interception. And what I want to show you there, that pink bar shows more or less what would be the levels of Brix that you would find in vinifera cultivars. So our cold-hearted grapes are not really that much difference from the levels that you can achieve in vinifera, and this is a very general range, so it will vary depending on the cultivar. So this is the same. This is Brix for the white cultivars. So we have Brianna on the left, and we have La Crescent on the right, and again, the bar that is with the stripes is the bar with the exposed fruit, and the solid gray one is the control. And we didn't see a major difference or any trends in terms of Brix between the 2 cultivars. And these are, again, the range of what you would expect to have for vinifera cultivars, just to make a comparison. However, when we look at the acidity, also the titratable acidity at harvest, this is for Frontenac, Marquette, and Petit Pearl, and we look at the range for the vinifera cultivars, well, as we said before, these cultivars tend to have a much higher acidity, and is absolutely the case for Frontenac, and is also the case for Marquette. However, Petit Pearl, which is this new cultivar, seems to have intrinsically maybe a lower acidity than the other two cultivars. But what's interesting is we did see a significant reduction in titratable acidity in all of the years for the treatment, the exposed treatment. And when we look at more or less what is that percentage of reduction, in the case of Frontenac, can all the way almost to 9.5 to 6.5, and this will depend on whether the year was a warmer year that naturally we had warmer temperatures, or it would be a cold year in which the effect of the treatment of exposing those clusters might be much more pronounced, because in general the year is cold, and by opening up the canopy you can increase much more the temperature difference between the two. And so all the way to Marquette, where we can get, you know, maybe around 3% difference, and in some years up to 7.5%. In the case of Petit Pearl is where we saw most of the variability. One year we saw up to 20%, while the following year we almost did not see much of a difference. So we saw quite much more variability. But again, overall, Petit Pearl seems to have lower acidity than the other two cultivars. In the case of the white cultivars for the TA, you can see the pink bar again highlighting what the vinifera ranges are for TA at harvest. And Brianna seems to have lower acidity than La Crescent. I know a lot of growers know that, but we again saw a significant effect of the treatment, of the exposed treatment in the TA for all of the years for Brianna and for La Crescent. And again, the range changed depending on the cultivar and the experience of the year, but anywhere between 15% to, in the case of Brianna, no difference in last year. Another thing that we did, and I don't want to go a lot into details on this, but we look specifically at malic and tartaric acid, the two main acids that are part of this titratable acidity that considers all of the acids in the fruit. But malic and tartaric are the most important. And so what we saw when we were specifically looking at these two is that for 2015 and 2016, the 2 years that we looked at these two acids, is that we see a steep drop of malic. That is what we would expect it, and it was significant not in all of the years and all of the cultivars, but we did see significant differences. And I just want to point out that most of the drop in the TA is due to the drop in the malic acid that is the result of that higher temperature of the berries. So in summary for this part of the study, I would say that the leaf removal around the fruit zone did increase sunlight and temperature of the berries. We did not see a major effect on soluble solid concentration, so on Brix. We did see an effect on TA, titratable acidity, between 5 to 10% reduction. However, we also discovered that cultivars like Brianna and Petit Pearl have intrinsically lower acid levels than our more traditional cold hardy cultivars. I want to point out that we did not see any effect on yield for any of the treatments for the majority of the cultivars, with the exception of Brianna. We did see a negative effect of the exposed treatment on yield. We saw a reduction in yield, and one of the reasons why we think we saw this reduction in yield for Brianna is that Brianna is a cultivar that tends to have really big leaves with long internodes. So it doesn't have a lot of leaves, but it has very big leaves. And we hypothesize that probably the removal of those leaves right after fruit set might potentially have affected the production of carbohydrates that are feeding those clusters to make them bigger and also to grow those berries. So we did see a significant negative effect on Brianna. However, we did not see a negative effect either on Marquette, Frontenac, Petit Pearl, La Crescent, and I have to say we also did this in Foch, in Léon Milliot, And we also tested a lot of other cultivars, and in neither of them we saw a negative effect of the exposed treatment on yield. And here is the big question: is this really worth it? Cost effect of doing the practice of going and doing all of this leaf removal to decrease the TA between 5 to 10%. I mean, that is something that may be coupled with some management in the winery to even reduce a little bit more acidity, could pay off in achieving wines of higher quality. So that is something that, you know, we haven't done the economics of what it costs to really go out in the vineyard and do this leaf removal. But as I said, we only did it once, and we did have pretty significant effect. So the second part of the study that we did under the same setting is we wanted to look on the red cultivars if this increase in sunlight would affect the phenolic compounds, so the concentration of phenolic compounds. And phenolic compounds are it's very broad. There are many different chemical compounds that are part of phenolics. But one that I want to highlight is anthocyanins, which again I already said is the main source of pigmentations in red wine. As I was explaining previously, cold hardy grapes tend to have a different type of anthocyanins that the color might not be as vibrant as the color of the anthocyanins in the vinifera cultivars. And we wanted to look specifically to see if we saw an overall change in phenolic compounds. And then we went a little bit deeper and we looked specifically to changes in anthocyanin concentration. But we also wanted to look at, is this change in color translating into change in the formation of color compounds that are more stable and can basically last during aging process of the wine. So that is the percent polymeric color. So this is a graph that shows the effect of the treatments on the total phenolic in the juice at harvest. So basically we sample berries at harvest, we took out the juice, and we analyzed how much phenolics there were, total phenolics that were present in the juice. This is a relatively simple test that we can do in the lab. And I'm going to explain how the graph reads. You can see on the y-axis, it's just the unit in which we measure total phenolics. And in the bottom, in the x-axis, you see MQ for Marquette, which is all the bars in red. Petit Pearl in the middle, which are all the bars in black. And Frontenac on the right, which are all the bars with green color. We analyzed juice for the harvest of 2015, 2016, and 2017. The bars that are solid color, just as in the previous slides, are the control treatment, and the bars that have stripes are the exposed treatment. So what did we see? We see that for all of the years in Marquette, when we analyzed total phenolic concentrations in the juice at harvest, we had higher concentrations in the exposed treatment. In the Petit Pearl, we actually did not see any significant differences. However, in Frontenac, again, the exposed treatment, the fruit that was exposed, had higher concentrations of total phenolics of the juice at harvest compared with the control. Then we wanted to see, well, does this actually translate into higher phenolic concentrations in the wine? So for the harvest of 2017, we made wine out of this fruit. And when we look at the concentration of total phenolics in the red wine, we see that for Marquette, there was no significant difference between the control and the exposed treatment. While for Petit Pearl and Frontenac, we did see an increase in total phenolics in the wine with the exposed treatment. As I said, then we move into looking at, well, we have total phenolics. Can we, within the total phenolics, can we look specifically at anthocyanin concentration? So the concentration of these compounds that give us the pigment. And what we have here is the monomeric anthocyanin concentration at juice So again, the same type of graph. You can see on the y-axis is the concentration, the unit of the concentrations in which we measure anthocyanins, and then in the x-axis is Marquette on the far left, Petit Pearl in the middle, and then Frontenac on the right. And for the 3 years that we did the study, we saw no difference in anthocyanins in the juice for Marquette. However, we did see a significant difference in Petit Pearl and Frontenac for all of those 3 years, with the exposed treatment having higher concentrations of anthocyanins than the control. And then obviously we looked at the wine, and as I said, we only made wine 1 year, it was in 2017. And what we saw in the wine, when we looked at does the higher concentration of anthocyanins in the juice translate in higher concentration of anthocyanins in the wine, we actually saw that for the 3 cultivars, Marquette, Petit Pearl, and Frontenac, you can see that there's a significant difference denoted by this little asterisk there, in that the exposed treatment had higher concentrations of monomeric anthocyanins than the control. And that was true for all of the for all of the cultivars that we evaluated. So as I explained, there's anthocyanins that are the main source of pigmentation, but as the wine ages, those anthocyanins that are giving the red color to our wines are not very stable, and they can break down. And so for them not to break down and to lose some of the color, there's a process that happens in which those anthocyanins are react with other components to stabilize that color. And so that can, continue during the aging process of the wine. And so there's 2 main ways in which that color stability, the formation of these stable color compounds can happen. One of them is through a process that's called co-pigmentation, which basically all of these anthocyanins would associate with each other, that can stuck with each other, or they can also associate with a smaller non-color organic compounds. That's a process that's called co-pigmentation. But there's another process, very well known and very important, in which the anthocyanins can interact mostly with what we call condensed tannins, which are tannins that are in the skin of the berries and also in the seeds. And they form very stable components that would help with the aging and the color stability of the wine. As I said when I was describing at the very beginning of the presentation, one of the differences that we have in the cold hardy grapes is that the amount of these condensed tannins that they are free and available to react with the anthocyanins tend to be low, because there's a protein in these cultivars, in these cold hardy grapes, that binds with these tannins. So these tannins are not available for the formation of these polymeric pigments. So that's why we have a little bit of problems with the color and the color stability of red wines in cold hardy grapes. So all of this to say, we knew that we had more anthocyanins. Now we wanted to know, well, do we have any increase in this more stable color compounds concentration? And when we looked at the wine again, and we measured this, what is called the percent polymeric color, a little bit more of the stable compounds, we actually again saw quite a significant effect of the exposed treatment, in that for all of the cultivars, for Marquette, Petit Pearl, and Frontenac, you can see that there's a higher percentage of this polymeric color in the exposed treatment compared with the control. And you can see that that is actually significant for all of the cultivars. So as a summary of this second part of the study, in short, cool growing season, as we have here in Wisconsin, increasing the light exposure through the treatment that we applied resulted in a higher phenolic content in the juice and the wine. It also resulted in higher monomeric anthocyanin concentration in juice and wine. And as I just showed, we also saw there's an increase in this percent polymeric coloring wine, which is the percentage of these stable color compounds. So overall, we believe that this treatment, that increasing the exposure of the clusters to sunlight, can have a very positive effect in terms of color development for these cold climate grapes. So with that, I think that's everything that I had in terms of presentation. I just want to acknowledge a lot of people that had worked on this. This is quite a bit of intensive amount of work. So I want to acknowledge our funding. So the Department of Agriculture, Trade and Consumer Protector of Wisconsin that has funded a lot of these studies. The Wisconsin Grape Growers Association that also have been a great supporter of the work that we do in my lab, and everybody that has worked in my lab, Beth Workmaster, Jean Riester-Loper, that she did all the work with the acids and the sugars, and my student Jacob Schafferter, who did all the work with the phenolic and the anthocyanins and the wine. And with that, I'm open to any questions.
All right, thank you, Amaya. That was really interesting. If anybody has any questions, you can go ahead and type them into the Q&A bar, which should be available at the bottom of your screen.
Okay, I'm just going to put it here so I can read some of those questions. And I don't know, Janet, maybe
right now,
you want to read it to me?
Yeah, there isn't anything there currently, but hopefully if anybody has any questions, they're gonna be typing those in.
So I can see one that says, can you go over again the mechanisms, exactly what you did with the removal of the leaves? So again, so what we did is, and I can probably go back. Whoops, I can go back here. I don't know. This was allowed me, but what I want to say, okay, so what we did is we, 2 weeks post fruit set, so 2 weeks after the fruit had started to set, and the berries were more or less the size of a pea, we went there and we removed between 2 to 3 leaves around the clusters, and then we also removed the lateral shoots that were emerging from the first 3 node positions in the shoot. And that way we open up that section and we increase the amount of light that we were receiving there.
I actually had a similar question to that, which is just whether you think it might be possible that removing either more or fewer leaves might lead to a stronger effect on that, the TA reduction in particular, and how you chose, I guess, how did you choose 3 leaves in particular to remove?
Well, the question is like, we wanted to do the minimum possible, thinking about what would be something that the growers would actually want to do, and in a time of the year that maybe things are yet not as crazy as they get as the season progresses. So that's how we decided to do only between 2 or 3, and we consider that the clusters, and you can see in the images that I show, there's quite a bit of difference. You can see clearly that the clusters are very well exposed in the treatment just by removing, as I said, 2 or 3, and the lateral shoots that also, can produce quite a bit of shade.
Sure, that makes sense. One question that Eric had was whether you plan to do the experiment. I guess he's talking about the fruit chemistry experiments with removing on both the east and west side.
Sorry, we actually did remove on both sides. So we removed for every shoot that we had that had a cluster, either was on the east side of the canopy or the west side of the canopy, we removed, for each one of those shoots, we did remove the leaves and the laterals. So in every single one.
On both sides.
So we went both ways. We went on the east side of the canopy and on the west side of the canopy. And I have to say, all of the Marquette, Frontenac, and Brianna and La Crescent were trained in VSP, vertical shoot positioning, while Petit Pearl was the only cultivar that we had trained in what would be a mid-high wire cordon. So a high cordon, basically. The cordon was around 5.5 feet from the ground, and it was trained down.
Okay. Hi, Amaya. This is Tim. If I can just jump in here with a couple questions of my own. One question is, did you shoot tip and hedge these, and did you see you know, aggressive lateral growth after you did that on the lower canopy? Because that's sort of what we saw in New York, and I just wanted to, you know, congratulate you on these studies. Real similar results to what we found up in northern New York with stuff we did on Marquette, at least, where we looked at sunlight exposed clusters and shaded clusters within the same vine, and saw some of the same trends in reduction of acidity, for example, and and temperature that we saw, that you saw there. So my other question is, you know, one of the other things we found out is that we got bigger clusters and higher yields when we did high cordon with, particularly with Marquette, but also with Frontenac. Do you think that having these on high cordon, that you'd see the similar results with the leaf removal, or you know, or would they intrinsically have more exposure, you know, being on the top of the cordon?
Both of your questions, excellent questions. I have to say, we in the VSP trained cultivars, we did hedge at least twice during the growing season, and that's a problem that, I mean, as I said, we have so much rain, and we have very fertile soils, and cold-hardy grapes intrinsically are very vigorous, so we have vigorous vines. But I don't think they were the result of either the leaf removal or the lateral removal. We did not see, visually, we didn't evaluate this, but visually we did not see a difference in the vines that we did the treatment versus the control in terms of having more laterals in the top portion of those shoots. Marquette is always, to tell the truth, the big pain, because it has so many laterals that whether you do it or you don't, you ended up with a lot of laterals. But we did hedge. In the case of the Petit Pearl that was trained on a high cordon, in that case, I think that maybe if we skirt maybe once. Petit Pearl tends to be a very well-behaved cultivar. It's way less vigorous. And in that case, we were surprised that we actually still saw the difference in the treatment on the high cordon. Mm-hmm. I think that your point, whether in a high cordon system, we will naturally see more exposure, and then we would see this effect happening even without the treatment. I think that you're right, that you tend to have more exposure in the high cordon. However, we also have it's incredibly difficult to control the vigor even with high cordon. And so we still get a lot of our clusters, because we tend to have more clusters in a high cordon. We still have a lot of them inside the canopy, very shaded.
Yeah.
So I think that it would still benefit. But again, that was part of my summary is, well, I think that the growers really need to assess whether it's worth it to reduce acidity between 5 to 10%, if that's your objective, with this or not, and whether this may be coupled with something that we can do in the winery that can even further reduce acidity. Could be two available tools for growers and winemakers to try to reduce acidity of these wines.
Yeah, that's a really good point. And I guess some experience I've had with some Vermont wineries that have things on a high cordon, but spend a lot of effort in manual leaf and lateral removal, to the point of having, I don't know, 3 or 4 people for 6 weeks, doing nothing else but that. That points to, they get some great results with that, but that points to really high cost of labor. And, I would hope that there would be a way with high cordon to mechanize this somehow, so that you could do it with a machine.
Yeah, that will be ideal. Other things that we've learned, I gave a webinar, I think like last year, when we had this study with the different training systems, and in talking a little bit about the different training systems, we used to have a very high cordon, and so we've changed it, a lot of our VSP in what we call the mid-high cordon, that we have our cordons around 5 feet high, which makes it a little bit more manageable. Another thing that we've been doing in trying to get ahead of the craziness of the laterals is come in and comb, if we can, those shoots early on when they're just starting to grow, and do this lateral shoot removal very early on, because afterwards it's almost impossible to try to get into those canopies.
Another question, this is kind of pushing two together, but did you either measure or kind of see any effect of the leaf removal on either diseases or bird pressure?
No, we did not measure it, and that's something that we are interested in, if we would see any difference. We did not measure it, so I cannot comment on it, and visually we did not see anything. But I have to say, I mean, we obviously do spray the vineyards, and we try to keep you know, very well control of diseases. However, we have had a couple of years, and if you look closer at some of the graph, you're going to say, wow, that acidity looks really high, and that Brix look really low. In some cases, we had to harvest much earlier because we had some fruit that was breaking down. Now, here's a question: is this really a tool that maybe in one of those years might help you, because you know you started with a lower acidity already just by exposing those, and an earlier harvest, you know, you could see maybe a little bit more difference between the two treatments. It might be, but we did not evaluate that.
Okay. Another question from Paul is, what sensor were you using to measure the berry temperature?
We were just using microthermocouples connected to a data logger.
Okay. And also, do you have an estimate of approximately how much time you spent on pulling those leaves? Or also a question that I had to go along with that is there any way to mechanize that you know of?
I think that there are some, obviously not an expert on this, but I'm pretty sure that I've seen that there are some mechanical leaf removals for, especially for VSP. I don't know if there's anything like that for high cordon. Maybe Tim has more information about that, but I've seen vinifera that they are. And we spent, you know what, it was very fast because it's early on. So it didn't take us a lot of time. We moved very, very, very fast doing this, because as I say, it's 2 weeks post bloom, basically. So there's not a lot of extra material. It's very easy to access the clusters and the shoots in the high cordon and also in the VSP. The VSP obviously is much, much easier because you have the fruit right there in front of you. So it was very manageable time-wise. We usually were around, you know, 4, 2 on each side, and you know, it didn't take us more than a morning to apply all of these treatments. So I would say for sure less than a minute per vine. Maybe like 2 or 3 minutes in the entire four vines in a panel.
Okay, so pretty quick.
Yeah, I'll jump in here and say that there is a new type of leaf removal machine that uses air blasts instead of suction and cutter knives to remove the leaves. So I'm thinking that might have a really good potential for some of these high cordon situations where, you know, it doesn't really contact the leaves. It doesn't pull the clusters out. It just uses the air blasts, and they typically, you know, they will hit the leaves more than the clusters.
Another question from Rich is if you have any idea why there's that difference in between the fruit and the wine phenolics. So when you showed the difference between the treatments for fruit had a different effect than for wine, and I think they sort of flipped where some of the varieties were different.
Yeah, it was mostly Marquette. I mean, Marquette, we got some strange results there. I think part of it is that in a couple of years, we had some of our clusters, and this is something that, you know, maybe other growers have seen, and I know that some growers in Minnesota have seen this. We've been seeing like our clusters start desiccating closer to harvest. It's not a disease problem, but we saw some breakdown of our berries. It's mostly the rachis starts drying up, and then the berries start drying out. It's not black rot, it's not any disease. We had the pathology look at it, and it doesn't look like it's any disease. And so I think that maybe those kind of different results, or these flips of the results, were due to some of the clusters maybe being a little bit more dehydrated, especially for Marquette. But we did this not only for the varieties that I presented. We tested, as I said, on at least other 5 varieties, and we did see consistently the increase in the total phenolics in the juice, and then it would carry over to the wine as well.
Okay. Another question was having to do with sort of the year-to-year sort of long-term effect of doing this leaf removal. And I believe that your method, you had the panels were the same for the 4 years, or did you randomize
Yes, so
them?
what we did is in each panel that we had, we divided 2 of the vines were a control, and the other 2 vines right adjacent were the exposed treatment, and we did it on the same vines during the 4 years.
Okay. And do you have any indication if there might have been a long-term effect of leaf removal on fruitfulness or berry size or yield or anything like that?
No, as I said again, we did not see any effect. The only negative effect that we saw on yield was for Brianna, in that we saw lower yields in the exposed treatment. And as I think that probably is due to those shoots being a little bit less leaves, bigger leaves, longer internodes. So removing one leaf is a lot of photosynthetically active area that you're removing versus removing maybe 1 or 2 leaves on cultivars that tend to have smaller leaves.
Okay, that makes sense. And about how many clusters did you allow per vine? Or were you controlling for that at all?
Well, what we did to standardize is that we had around 6 to 7 shoots per foot. So we did a quick, when we were pruning, and then we did shoot thinning to make sure that we had sort of like same amount of shoots per length of cordon. And we tried to standardize it in all of the vines.
So
but we did not see any difference in fruitfulness. We didn't see less clusters.
Okay.
Yeah, Maya, did you take pruning weights on any of these, or?
Yes, we did. We do have all of that. I don't remember it from the top of my head, but we did not see any difference on pruning weights either.
Okay, thanks.
Okay. I think I have addressed most of the questions on here. There's one from Stephen Cummings, which is a little bit kind of to the side of the question, but I'm going to go ahead and read it. Has anyone had any experience with losing color intensity when using clarifiers, especially, I'm not sure this word, the chitosan, crustacean 2-step type? I know this isn't necessarily your specialty, Amaya, but.
No, I'm sorry, I can't answer that question. I'm already a horticulture person learning about viticulture, and way less do I know about wine. So absolutely out of my area of expertise. Okay. I'm sorry.
If anybody else has something to respond to that, you could just type it in the chat bar. And if anybody has any other questions that maybe I missed or that you haven't asked yet, go ahead and type those in. And we'll just give everybody another minute if they think of anything. I guess you kind of, you sort of addressed this a little bit, but I was just wondering the difference in the TA between the exposed, the shaded and the exposed just looks to me, you know, like it's not very big of a difference. And I guess my question would be sort of like, what's the difference as it moves through to making a wine or to the bottom line? And I know you haven't like actually studied that, but I'm just curious if you have sort of a gut feeling of, is that narrow of a margin of TA difference something that is going to be you'll be tasting in the wine at the end of the day, or is going to affect the price?
That's a good question. I really don't know the answer, but I would say that a 5% or a 10% difference in TA in something like Frontenac, where you can have, you know, a TA of 17 grams per liter, it must make a difference.
Yeah. Okay.
But we didn't have any tasting panels of the wine. We didn't do that.
Okay. Is that something you might think about including, or it's just kind of outside the scope?
Well, if we had the time and the availability of doing something like that, we would love to do it.
Okay. Another question, I think maybe you already answered this, but did you find any difference in berry size in the
No.
different treatments?
No, we did not, and
Not
we know
yield,
that
not size.
because we collected samples of 30 berries and we weighed them, and so because those were the berries that actually afterwards we did all of the analytical work, and so we did not see any difference at all.
Okay, and sort of approximately how many clusters per shoot? I know you already said that there were 6
Per shoot?
6 shoots, but approximately how many per shoot? Yeah.
In general, we almost always had around 2, between 1 and 2, not more than that. Very rarely have I ever seen 3 clusters.
Okay. I think that's all the questions that we have open. Tim,